Welcome to the General Chemistry 2 class. This section is on chemical thermodynamics. This lesson is about Gibbs free energy. Let's begin. In this lesson, we will use Gibbs free energy to determine the direction of a reaction. The total entropy or the entropy of the universe for a spontaneous reaction is increasing. Determining the spontaneity of a reaction is also possible by just looking at the thermodynamic quantities pertaining to the system alone, even without looking at its interaction with the surroundings. The entropy change of the universe is equal to the sum of the entropy change of the system and that of the surroundings. This sum is greater than zero for a spontaneous reaction, hence the inequality. 1. At a constant pressure, the entropy change of the surrounding is equal to the negative enthalpy change of the system divided by the temperature. Substituting this for the entropy change of the surroundings in inequality. 1 gives us inequality. 2. Multiplying both sides by t yields inequality. 3. Multiplying both sides by negative 1, which results in reversal of the inequality sign, gives us inequality number 4. The box expression in inequality 4 is equal to another thermodynamic quantity, the Gibbs free energy change or delta G. The Gibbs free energy, also known as Gibbs energy, is the energy available for a process to do work, like enthalpy and internal energy. Gibbs free energy is a state function or a function that concerns only the initial and final states. From the equation we derived earlier, we see that the Gibbs free energy change is decreasing for a spontaneous process. Thus, the reaction is spontaneous in forward direction. If the Gibbs free energy change is increasing, the reaction is spontaneous in backward direction. When the Gibbs free energy change is equal to 0, the reaction is spontaneous in both forward and backward directions. The Gibbs free energy of formation is a change in Gibbs free energy accompanying the formation of 1 mole of a substance from elements on their standard states. At 1 atmosphere and 25 degrees Celsius, this quantity is called the standard Gibbs free energy of formation. The Gibbs free energy of reaction is the change of Gibbs free energy accompanying a chemical reaction. At 1 atmosphere and 25 degrees Celsius, this quantity is called standard Gibbs free energy of reaction. There are 2 ways of evaluating the standard Gibbs free energy of reaction. The first one is by using the standard enthalpy or heat and the standard entropy of reaction. And the second one is by using the standard Gibbs free energy of formation of reactants and product. The standard Gibbs free energy of reaction in terms of standard enthalpy or heat of reaction and standard entropy of reaction is given by the following equation. For a hypothetical reaction, reaction A and B forming C and D, the standard Gibbs free energy of reaction is equal to the sum of standard Gibbs free energy of formation of all products less than the sum of standard Gibbs free energy of formation of all reactants. Note that the stoichiometric coefficient of each substance is the balance equation taken as a multiplier of the standard Gibbs free energy of formation of that substance. Example number 1. Calculate the standard Gibbs free energy of reaction for the formation of aluminum oxide given by the standard enthalpy of reaction equals negative 1675.7 kilojoules per mole and standard entropy of reaction equals negative 313.4 0.408 joule per Kelvin mole. For the solution, the standard Gibbs free energy of reaction is equal to the standard enthalpy of reaction minus temperature times the standard entropy of reaction. Since the given standard thermodynamic data is measured at 25 degrees Celsius or 298.15 Kelvin, we will use this temperature in the calculation. Substituting the given thermodynamic data with proper conversion units gives us negative 1,582.2 kilojoules per mole. Example number 2. Calculate the Gibbs free energy of reactions for the decomposition of carbon dioxide gas given thermodynamic data tabulated on the right. For the solution, we first write the equation for the standard Gibbs free energy of reaction in terms of the standard Gibbs free energy of formation of the reactant and the products. We start from the sum of standard Gibbs free energy of formation values of products, followed by subtracting the standard Gibbs free energy of formation of the reactant. Do not forget to include the coefficients from the balanced chemical equation. Substituting the given values, we obtain the standard Gibbs free energy of reactions, which is equal to 257.2 kilojoules per mole. Example number 3. Determine the direction of spontaneity of reactions in example 1 and 2. As for the solution, the reaction in example 1 has a standard Gibbs free energy of reaction that is less than 0, hence the reaction is spontaneous in forward direction. The reaction in example 2 has a standard Gibbs free energy of reaction that is greater than 0, thus the reaction is spontaneous in backward direction. Enthalpy and entropy effects. Now we will look into the conditions at which a reaction proceeds spontaneously in either forward or backward direction. For an endothermic reaction whose entropy change is positive, reaction is spontaneous in forward direction at high temperatures and backward directions at low temperatures. An endothermic reaction with negative entropy change proceeds spontaneously in backward direction at all temperatures. An exothermic reaction with positive entropy change is always spontaneous in forward direction. An exothermic reaction with negative entropy change favors the reaction in backward direction at high temperatures and the forward reactions at low temperatures. Phase transitions. Phase change or phase transition is a process in which a substance phase is changed from one state to another. The different phase transitions are fusion or melting, evaporation or evaporation, sublimation, freezing, condensation, and deposition. The equation for Gibbs free energy corresponding to phase transition is given by the following equation. During the transition, both the initial and final phases exist. Consequently, the Gibbs free energy of transition is equal to 0. Solving for the entropy of transition, we have entropy of transition equals enthalpy or heat or transition divided by the transition temperature, which is the temperature at which the phase change occurs. From this equation, we can arrive at the corresponding entropy changes for fusion, evaporation, and sublimation. Since freezing, condensation, and deposition are the reverse of fusion, evaporation, and sublimation, respectively, the accompanying entropy of transition is negated. Example number 4. The heat evaporation of acetone is 29.1 kilojoules per mole. Given at the boiling point is 56 degrees Celsius, calculate the entropy evaporation of acetone. Solution. The entropy evaporation is equal to the heat evaporation divided by the boiling point. Substituting the given values of enthalpy, evaporation, and boiling point, With the conversion of units from kilojoules to joules, we obtain entropy evaporation, which is equals to 88.4 joules per Kelvin mole. Conclusion. To summarize, the Gibbs free energy delta G is a thermodynamic quantity that describes the spontaneity of a reaction. If delta G is less than zero, the forward reaction proceeds spontaneously. If delta G is greater than zero, the backward reaction is spontaneous. And if delta G equals zero, both the forward and backward reactions are spontaneous. That would be all. Thank you. Welcome to the General Chemistry 2 class. This quiz is about the Gibbs free energy. Let's begin. Number 1. Match each condition in column A with the correct direction of reaction spontaneity in column B. Number 2. Which of the following mathematical statements is true for Gibbs free energy? Select the correct answer. Number 3. Which of the following statements is not true about the Gibbs free energy of a reaction? Select the correct answer. Number 4. What is the standard Gibbs free energy of the reaction? Select the correct answer. Number 5. In which direction is the reaction spontaneous? Select the correct answer. Number 6. What is the standard Gibbs free energy of the reaction? Select the correct answer. Number 7. In which direction is the reaction spontaneous? Select the correct answer. Number 8. What must be the signs of the enthalpy change and the entropy change to be consistent with the direction of spontaneity in the third column? Select the correct answer. Number 9. During phase transition, what is the value of the Gibbs free energy? Select the correct answer. And last but not least, number 10. Which of the following equations is correct about the entropy of transition? Select the correct answer. That is all. Thank you.